Hello dosto. So in this series of dynamic programming, today we are going to start our very first lecture of introduction, which is what is dynamic programming. So the first thing as a student, what we do, we just start typing the same thing on the Google, we search over it, like we read Wikipedia, we read different websites, or even you may read some books to know what is dynamic programming. So what I've done, I've taken a definition that you are going to get whether you're going to read a book or maybe from any website. So let's read it once. So dynamic programming is an algorithmic technique for solving an optimization problem by breaking it down into simpler subproblems and utilizing the fact that the optimal solution to the overall problem depends upon the optimal solution to its subproblems. Okay. Yes, the definition is clear, but अभी वो feel नहीं आया ना dynamic programming क्या? Okay, what if I tell you that I can define dynamic programming in 2 words? It's simply an efficient recursion. If anyone asks you what is dynamic programming, it's efficient recursion. Or I also use one term that I have coined myself, which is like polynomial version of recursion, and some people call it optimization over recursion. Okay, wait. For people who don't know what is recursion, it's basically, you can say, a mathematical function. And if you're talking about mathematics, then it's a mathematical function which depends upon itself. In coding, we can say a function which call itself is a recursive function. Cool? Easy. So this is what dynamic programming is. Whenever someone asks you, just say it's an efficient recursion. So people who know recursion, you might be wondering, what, recursion? Yes, it's just simple, efficient recursion. That's all. Now, in order to feel exactly what is dynamic programming, let's take an example. सबसे बढ़िया समझ में तभी आता है ना जब अपन एक उदाहरण के साथ लेते हुए चलते हैं कि यार ये एग्जाम्पल के अंदर है और ये डेफिनेशन है, तो थोड़ी चीजें क्लियर भी होती है. ओके, सो लेट्स स्टार्ट. फॉर पीपल हु नो व्हाट इट इज, लाइक this number, the sequence that you are seeing right now. So some of you know what it is. For people who don't know, it's called as Fibonacci series. Now the series is so famous that you can see it in nature. Like whether you're seeing a sunflower, or if you guys watch National Geographic, then you'll be amazed that the square that the rectangle, that they use is basically based upon a Fibonacci series. Isn't it cool? So let's see the mathematical definition of Fibonacci series. So the Fibonacci sequence is basically this, where this is your 0th term, your first term, and it goes on. So how the term is generated is basically whatever the term that you need to find is the sum of the previous 2 terms. So 1 plus 1 gives you 2. Now suppose you want to find 8, then that will be the sum of the previous 2 term, which is 3 plus 5, it gives you 8. So that's what written here. The next number is found by adding up to 2 numbers before it. Okay, people who know Fibonacci series might be thinking, okay, let's just skip it. But let me tell you guys, towards the end of the video, I'm going to show you that how with the help of directed acyclic graph, we are going to represent that in a Fibonacci series in a graph, and we'll see that how table is filled. Like if you guys have ever wondered that why bottom-up approach is filled and the way it is filled, or how top-down approach is filled, so we are going to see that towards the end. So make sure that you watch all this. Okay, so let's move ahead. So whenever you see whatever the question you're given to you as a Fibonacci series, the next thing we do, we try to write in a mathematical form. Okay, so let's write it is called as a recurrence relation. So a 0th term is 0 and a first term is 1, because this will be like some of the base condition. You cannot ask for you cannot generate the first term, because what is the sum of the previous 2 terms? One will be the 0th term, but we don't have a negative term, right? So in order to find the nth term, what you do, you basically, that's what the definition say, the nth term is the sum of the previous 2 term. Okay, if it's looking odd to you, then let me tell you, it's the same, we used to write f of x, and guys, if you guys, in your 10th or maybe I guess in 8th, there was function relation chapter or something like that. So in which we used to see that a function is related to, x square plus x, or something like that. Anything, I mean. So it's basically the same thing. Whatever I've written here, fib of n. So whatever I've written fib of n is basically the same. It's f of n is equal to f of n minus 1 plus f of n minus 2. Well, this is sort of the very first step that we do. Whatever the question has given us, we convert that into a mathematical formula, okay, which is our recurrence relation. So I've converted the question into fib of n is equal to fib of n minus 1 plus f of n minus 2. Now let's code this formula that we have written here. So let's code this formula. Friends, I'm going to use C++ language. If you want, you can use any language. So before writing our code, let's see a basic structure of any recursive function. So a recursive function basically consists of a base condition. So a base condition is something which is going to make your recursive function to halt, because it will, if it keep calling itself, then there will be like infinite number of calls. So these are those conditions which basically, which when becomes false, your recursive function stop calling itself. Okay. The next thing what we do, we write our recurrence relation. So our recurrence relation is the relation of that function with itself. So here in dynamic programming, we'll call it as a selection diagram. So whatever we are going to get from a selection diagram, we are going to code it here. So the last thing is we return whatever the answer we get. तो काफी सिंपल है, इसको कमेंट कर देते हैं. Okay, so return type of our function will be int, as we are returning an integer. Now I'll call my function as fib. So let's pass the parameter which be int n. So our parameters are of basically two types, like there are static parameters and dynamic parameters. So dynamic parameters are those which keep changing when you call the function. So here our n is a dynamic parameter. Why, you will come to know. So first we need to write a base condition. So what are the base conditions? Think for a moment. Okay, so a base condition will be when n equal to or 0 or the 1. So you cannot call for those terms, right? So because before those two terms, like your 0 term and the first term, it will become a negative term. So we don't have answer for that, or it's not defined for those numbers. So let's say for n equal to 0, this will be a one of a base condition, will return 0. And for if n equal 1, will return 1. Okay, so now we need to write a recurrence relation. So what was a recurrence relation? I'll just make some space here. Okay, so our recurrence relation was our fib of n is equal to fib of n minus 1 plus fib of n minus 2. So it's going to call a Fibonacci function, a fib function with the values parameters, the one term before it, n minus 1 term and n minus 2 term. So this will be our answer for fib of n if the n is greater than 1. So we'll simply return this. Okay, so this will be our simple recursive function for Fibonacci series. Okay, so we have done our recursion code. Now let's take an example. You know, the best way to visualize a code, as soon as you have written it, take an example and try to trace your code. Okay, so let's take an example. If you want to generate the number 21. Now as in Fibonacci, it's going to call the previous two terms. So first it will call the n minus 1 term and next n minus 2 term. Now this is going to call its previous two terms and similarly. Okay, pause the video for a second and look at the recursion tree that you're going to get from an input of 21. Just for a second and try to make some observation. Okay, you'll see that this tree follows symmetry. So the subtree that we are looking here for the 8 is the same subtree which is being called here. The subtree we are talking about here, which is getting us the value for the 5, is the same subtree which is generated here and the same subtree which is generated here. So my point is that when you are doing a recursion call, then there is like a lot of redundant calculation. So as you can see, the same function, the same subtree has been calculated thrice in the just a small input, sorry, in a small input of generating like 21. So my point here is, if there is some way that we don't have to recalculate it, then it can save a lot of time, right? And very obvious way to do is, if you guys have learned about an operating system, this simple of time and memory trade-off. So if you give memory, then you can increase the speed of time, right? Just like we uses cache in our CPU, or if you guys know, like the more RAM you get 4 GB RAM or 6 GB RAM, then that particular device is faster than the one which has 4 GB RAM, because it has increased its memory and it has increased its speed. Similarly, if we can store these values when we are calculating, then we can save a lot of time. How? Let's see. So when we are calling 21, 21 will first call 13 and minus one term, or just term before it. 13 will call 8, 8 will call 5, 5 will call 3, 3 will call 2, 2 will call 1, and as we know it's the base term, so we are going to get it. So it will return the value. Now when we are calculating for second, which is our third term, so we are going to store the value of the third term, then we are going to store the value of the fourth term, because it will return here. It will call 1, and we know that it's the second term which is already stored, so it won't be called. Now when for the 5 we are going to call 2, which is our third term, it's already calculated and we have stored it. Its value is 2, so we are not going to call this branch. Okay, very well. Now let's see when 8 is going to call 3. So we have already calculated 3. So we are not going to call this branch. We'll simply take the value which is 3 from here. And if you know, we'll also store the fifth term, which is our 5. So it will return the value. Now when it's going to call the 5, we know that our fifth term is 5, so it's simply going to return the value. So it will store the sixth term, which is your 8, and your seventh term, which is 13. So all these values are stored, so even this branch won't be called. Okay, now when 21 is calling for 8, which is your sixth term, we know we have already calculated. We'll simply look into our table, sixth term is 8, and we'll get the answer. So even this won't be called. So you see, when we store the values, how much calculation we are avoiding, or let's say the time we are saving. We have just calculated this leftmost subtree. That's all. So let's do whatever we have done in a recursion function. Let's store the value and let's see the difference in the execution time in the recursion and our memoization function. Memoization, okay. Spelling sahi hai bol raha hu main. Like when the first time I heard this term, even I was like memoization, and like sahi hai. Like term spelling dekhi yahi hai. Take hai, memoization. So let me make it very clear for you. It's basically when you store the values, then in the language of like computer language, we call it as memoization. So we have written a recursion function. Now we are storing the values. So that will be called as memoization. Okay, let's do it. So दोस्तों, ये था अपना recursive function. Now what we have to do, we have to just store the values. So in order to store the values, we need to define an array in which we can store it. Okay, so let's define an array. Okay, the first thing, how to decide what will be the dimension of the array. So here I'm using in 1D array. So the dimension is found by checking the dynamic parameters of a function. So here our dynamic parameter is n. Okay, why is that? Well, I'll take a very straightforward analogy. Now suppose in a 2D geometry you want to find out any point, like you want to store the value of any point. So what you will do, you will store the coordinates which define that point. What are those? X and Y. Now if you move to other point, only those two things will be changed, right? Your parameters will be changed from x1 to x2, y1 to y2. So in order to find any point, what you do, you store those parameters. So you store x and y values, right? So dynamic parameters are those parameters which basically defines the state of your function, with the help of which you can define that yes, what this function is called is different from the other function. Just like your x and y points define that this point is different from any other point. Okay, so here we just have single n parameter, and as you can see, we are calling with different values n-1, n-2, and it will keep on decreasing. So it's a dynamic parameter, and the number of dynamic parameter defines the dimension of your array that you're going to store. Okay. Okay, now suppose you want to, in C++, if you want to initialize your array, so you can use a function memset. The first thing is basically you just need to initialize your global array. So the parameters for memset is the name of the array that you want to initialize, the value we want to initialize 0, and the size of the chunk of memory that you want to initialize, so it will be dp of 0 into 1000. Okay, okay, now we want to store the value. So where is our answer? So this is our answer, fib of n-1 plus fib of n-2. So we need to store it. So what I'll do, I'll just simply write dp of n is equal to fib of n-1, n-2. That's it? No, I mean अगर तुमने अभी सिर्फ store करा है, अब तुम्हें उसको use भी तो करना है. I mean, what good it's going to give you if you're just storing the values and you're not using it. Okay, so what we need to do, we need to check that whether we have already calculated that particular value or not before calling this number, or sorry, before calling this nth term. So we need to check whether we have already calculated it or not. So let's say, I mean, we'll just check with the value if dp of n. Now if it is not equal to 0, that means we have already calculated it, and if it's equal to 0, then that means that we haven't calculated it yet. So just in case if we have already calculated, we'll just simply return the value that we have calculated so that we don't need to recalculate it. Now as you can see, it's very easy to convert the recursive or normal recursion to memoized recursion. It's just whenever you're returning an answer, you need to store it, and before calling the function, you need to check whether you have already calculated that particular state of parameters or not for that function. If yes, then return the value that you have already calculated. Cool? Okay, let's move forward. Okay guys, so we have coded our memoization. Now we have increased our time, there's no doubt in that. Like if you want, you can compare the execution time of both the recursion and the memoization, but still there is a problem. Like there is a reason why people went to this, you know, table approach. जो तुम देखते हो तुम्हारे friends को कि बस वो शुरू हो जाता है table बनाते हुए, तो table कहाँ से बनी और क्या हुआ, उससे पहले देखते हैं यार memoization में क्या गड़बड़ है. Like what's the problem in memoization? So you know, whenever a function is called, so in your memory, in your stacked memory basically, the state of that function, let's say for any function f, we want to find the 8th term, then when you're going to call the previous two terms, so it's going to save the parameters for f of 8 and the state whatever it's in it before calling the 7th and the 6th term, and likewise it's just going to occupy some space in the memory in a recursion function. So when you use a very large input, then it takes a lot of memory in saving the state of that function, which leads to a problem called stack overflow. Website भी है, ठीक है, मैं भी बहुत use करता हूँ. So what happens in stack overflow is just it occupies your memory, and just like this is the main reason why people, you know, then switch to from recursion to an iterative one, because they don't want their memory to occupy. It's very important to save the memory also. In memoization, we save the time. Now it's time to save memory also. So what we do, we convert our recursion function into a iterative solution. And you will see that that's something we call as dynamic programming, and that's how we came. But before that, let's try to visualize that how people come with an idea of this table approach or something like that. So we'll do it with the help of directed acyclic graph. For people who don't know directed acyclic graph, you don't need to worry. बहुत ही simple है. Like if you have like some points, your points in maybe any geometry. So I'll just call one of the points as A and the other point as B. Now, if those points are connected to each other with a directed vector, you can say, or a direction, so which basically signifies that you can go from A to B, but you cannot come to A from B. So it's just like one-way road. It's not a two-way road. So such type of graph are called as directed. As you can see, there is a direction which is involved. Acyclic, so there shouldn't be any cycle. So it shouldn't be like if you can go from A to B, then you're coming back from B to A. So that will create a cycle. So there shouldn't be any cycle, and yes, it's a graph. So this is what a directed acyclic graph is. So suppose, let's take example, say we want to find sixth term. Okay, so we want to find the sixth term. We don't know what is the sixth term of Fibonacci series. Okay, so before that, we need to calculate our fifth term. So this signifies the arrow that the calculation of this point is, in order to calculate this point, you need to first calculate this point. So we need to calculate the fifth point and we need to calculate the fourth term. Now, in order to calculate the fifth term, as we even don't know our fifth term, we need to calculate our fourth term and we need to calculate our third term. Similarly, for the fourth term, I mean, like, there is no magic. As you will see, like, even for the fourth term, you need to calculate the third term first, and n minus 2 will be your second term. So you need to calculate this also. For third term, you need to calculate the second term first and the first term. And for second term, your first term and your zeroth term. Okay, now we know our zeroth term is 0 and our first term is 1. So let's try to make an observation here. Like, all these points, no matter from where you start, are always going to point in this direction. That means these are the points which need to be calculated first, and followed by, once, like, suppose these 2 points are calculated, then we are going to calculate our second point. So second point depends upon, I'll just change the color of my pen. Okay, so as you can see, the second point depends upon the first and the zeroth term. So 0 plus 1 is 1. Now our third term basically depends upon the calculation of second and the first term. So we'll get 1 plus 1 from here, 2. Similarly, for the fourth term, it depends upon the third term and the second term, which is 2 plus 1, 3. Then we'll get 5, and finally we get our answer as 8. ठीक है, तो अब ये चीज देखना, like, if you guys have solved any dynamic programming question, so like when you create a table, then usually, usually your first row and your first column are always filled with some values, and people say like you're initializing them and all those things, but that's not the truth. The truth is that depends upon these 2 points. Like, just like these 2 points, they depend upon, these are some points which needs to be calculated first. Okay, so these are called as your base condition or your initialization. So in order to get the answer, you need to calculate these first. So now the observation tells us that it's need to follow the sequence in this direction. That is, we need to calculate for our I equal to 0 to n in order to find the nth term. So let's do it. Let's code our recursion function into an iterative function. So once you have written your Memoize function, it becomes very easy to convert it into your iterative solution, friends. So what I have done, I have taken our, like we were using a global array DP, now I'm calling it some local array fib DP. Now I'm taking an input C in nth term, which will be the term that we want to find. Now what we have to do is, whatever the base condition you have in your memoize function, that is your for n equal 0 and n equal 1, those base condition will become your initialization condition. So that will be your fib of dp. So your fib of dp for the zeroth term will be 0 and will initialize even our first term. So our first term will be 1. Now as you can see that the rest of the part in the recursion will only run when n is greater than 1. So I'll write that condition. If n is greater than 1, then we'll proceed. So the next thing what we have done, we have written a recurrence relation and we are storing as well as using the stored result. Okay, so instead of now calling it, we'll use an iterative. So for int I equal to 2. Now why I equal to 2? As you know, we have drawn a directed acyclic graph and every nth value were pointing to the smaller values, and it was starting from the very zeroth and the first term. So we have already calculated our zeroth and the first term. So the next term is our second term and we'll go all the way up to our nth term. So now we need to write our recurrence relation. So what was our recurrence relation? For any ith term, it will be the sum of the previous two terms, which will be your I minus 1 plus fib of I minus 2. Okay. So once you are done, your answer is in fib of dp nth term. That's all. Okay, now if you really want to appreciate whatever we have done, I'll strongly encourage you guys to take an input, say for n equal to 45 or 50, and see the execution time for normal recursion function, our memoize function, and our iterative function. So once you do it, you will be really amazed the difference that comes in all these three different methods that we have used. And the point is, you will appreciate more dynamic programming, that why we are using it and what wonders it does. So also you can share your results in the comment section. You can write the language that you were using and the execution time you got for all those three functions. Okay friends, so I hope now you have got a feeling what is dynamic programming. So now before proceeding further in this series, let's see what will be the flow of the lectures in this series. So there will be different classes. Okay, so what I've done, like as I told you, I've solved like some 200 questions before making this series. So what I like, when I was solving those questions, I found some relation between the questions and I started segregating them in different classes. So towards the end, I have like some 10 different classes. So I can be assured like 99% of the dynamic programming questions that you're going to get are going to fall in one of those classes. So in those classes, like there will be one template question, you know, just like in any object oriented programming, we have a class and then we create object from that template. Okay. So just like there will be a template question. If you solve the template question, then I'm going to tell you about like some dozens of questions, some 10, 12 questions, how those questions are related to that one single question. So what will happen is, like instead of solving some 150 to 200 questions, you're going to solve like some 10 questions and you will get a good idea like how those 150 and 200 questions are solved. And yes, definitely like 99% of those questions are going to fall in one of these classes. Now the thing is, there will be like a class 0. So class 0, it means like it won't be related to any particular class. You can consider it as like a parent class. I mean, those are the concepts which you can use in any of those classes. Okay. So let's see you in the next video where we're going to talk about the terminologies. And if you have liked the video, then hit the like button, subscribe the channel. And before going, I would like to thank Nimbus Education, you know, for providing all these resources and making this series happen. So also hit the bell icon button and see you in the next video. Bye friends.